Live.
Oh, we're live. Okay. So, hi everyone. Welcome to this week's Entry Live. And today we have Mike and Matt join us, and Amin join us this week, and we are gonna talking about the CNI. So, sorry, wait a second. Mike, would you like to tell us a little bit about yourself?
Yeah, totally. Thank you. So right now I'm currently engineering manager at Stateless. We're trying to make networking easy. Right now, I kind of have a background in networking systems, DevOps, and software engineering. I've been doing this since I was 10. And right now, the CNI has been a focus of mine for about a year or so now. So I'm quite pleased to be talking here.
Thanks, Mike. And we also have Matt join us today. So, would you like to talk about yourself? Talk a little bit about yourself.
Oh, sure, yeah. Hey, sorry, babe, my camera off now. I'm eating some food and don't want to look totally stupid. I work at Synopsys and I'm doing a lot of downstream Kubernetes. I did some upstream last year in the network policy space, and maybe sometime in the future I'll be able to present some of that stuff.
Yeah, we're looking forward to that. And welcome to this week's. And so, Mike, would you like to go ahead and tell us the amazing stuff you prepared?
Yeah, totally. Let me share my screen. I have it on my agenda. How do I share? All right, I'm going to be sharing my whole screen apparently. So, sweet deal. So, just what I'm going to be breaking down. I already talked about who I am. We're going to do a quick CNI refresher, the commands, inputs, outputs. We're going to break it down to a quick little diagram of what we're going to try to build, a simple control plane node and a worker node. We're going to go through the code workflow from kubectl all the way down to the specific plugins, also tying in containerd and cryo. And then we're going to jump into a few demos where we kind of just manually set up Kubernetes, just some manual steps, just so we see some of the moving parts where most people don't get to see. Then we're going to just use a quick little shell script as an example. Jay mentioned that he wanted to see the Cni Tool, so I brought that in as a quick example. Unfortunately, he's not here. And then if there's enough time, what I'm going to do is try to replace some of the static routes with a more dynamic approach using BGP. And that's kind of if we have enough time. I'm not certain how this will go. It may go over. It may go under. Did you want me to just kick it off there?
Yes, please go ahead.
Sweet deal. So let's go for it. We're going to just break this down really quick. I'm going to use Miro instead of Google Slides. So this will be probably a refresher for most people. I think everybody kind of had the, more than enough, experience with the CNI from the high level. Can everybody read this, or should I zoom in one more?
Yeah, I think it's better now.
Sweet deal. So let me know. I can just zoom in and I'll scroll a little bit if need be. So for the most part, we all know that the CNI is effectively, a specification to set up and tear down the network and verify it. So the CNI plugins all have various inputs or outputs. The high level ones you'll see is, our environment variables, which you could break down, the CNI, net, and S, which is actually a path to the specific, network namespace in this case. The actual spec doesn't actually specify, that you need to use network namespaces, which is a little confusing because it says CNI, net, and S. However, they, use the term isolation domain. The next one being the CNI container ID, which, is a source of confusion for some people because in Kubernetes, you can have multiple containers inside of a pod. So the container ID in this point would be actually the infrastructure pod. Infrastructure container ID. And then we have our most famous one that most people know is the CNI command, which we'll just, hit on that a little bit later, but we do have our add del check, and version, and possibly some more when it comes to CNI 2.0. Then we have our arguments and our IF, our interface name, which is generally ETH0, and CNI path, which can point to your binary location, generally your op CNI bin. And you can actually pass, you can pass multiple locations. So if you have op CNI bin or var CNI bin or more, you can actually do that comma separate it, or a semicolon or colon separate, depending on your operating system. So big piece right here is our CNI commands or operations. We have add, which I generally try to explain that sets the network up, or going back to more of the CNI specification, we're adding the container to the network. The delete obviously kind of just does the opposite. It removes the network, cleans everything up, or removes the container from the network. In the case that will show up above, we're simply deleting the network namespace, which detaches it from that Linux bridge. The other one right now is check, which verifies that the network is still in the desired state based upon cached information on disk. And then version just effectively says what version this CNI plugin will support. Next big piece of the puzzle here is what we call our network configuration. And there's actually two types of configurations. There's a network configuration, which is passed in via standard in. And then there's another one that's called the runtime configuration, which is passed in via the container runtime, which could be container D, cryo, or cry docker D. And we're going to be using this configuration a lot. We'll see it like 5 or 6 more times, but I wanted to drive in that this is effectively what we're going to be using. Keep in mind, one thing to note is that type references that directory and the CNI path, which in here will be op CNI bin. This is referencing an actual executable, and in this network configuration, we have a bridge and host local. So one for establishing a bridge network, and the other one for assigning IP addresses. And generally, actually, out of the container networking repo, we get some out-of-the-box default plugins, bandwidth bridge, DHCP, firewall host device, and more. I threw in VXLAN. It's not in existence yet. It's just something I'm working on. So these are all that usually you could pull down. They come down with, I think, kubeadm, and you install them. One thing that I think is helpful for a lot of people to kind of understand what the add and delete is actually kind of doing is most people how I think about it is that the add command or delete is effectively a blocking hook after the network namespace is created, but before the pause container is created. And that's obviously in the case of using Kubernetes. The same for delete. We actually will not continue on until that container or pod is actually effectively deleted. And in the world of the CNI, we actually have 2 types of plugins. We have interface and chained. And generally, I think in the documentation, it actually says like main and meta, which is a little confusing, but interface actually just creates the actual interface, and chained actually manipulates the state of that interface that was created or some piece of the state. I've already mentioned that we actually have a few container runtimes that support the CNI. This one, cry docker D, that's coming out of Runtimes since Kubernetes has since pulled the Docker shim out from 1.2.4. They have gone and created the cry docker D, which also supports the CNI. Oh, here's one important thing, that all plugins are actually executed in the root network namespace, and that they actually have information passed to them to have knowledge of the actual specific network namespace. That's via the CNI net and nest direct environment variable, which is sometimes a source of confusion. Some people don't know where these are actually executed, but they're just a simple executable. And one thing also to note is that there's been some confusion around the git tag versions and the CNI spec versions. They do not equal each other. So if you were going to actually specify version 1.0.1 in your actual network configuration, that will not work. and you'll have a ton of fun. So the git tag versions are generally associated with libcni and the releasable plugins. One thing to note is that, I'll zoom in one thing. I did mention that there's, two types of configuration, the runtime configuration and the networking configuration. But what comes first? If I specify two values, one in the runtime configuration and the other in the network configuration, which actually takes precedence, the runtime will override anything in a network configuration. So the network configuration is generally meant to be static, and the runtime configuration is built to be passed in through the container runtime. So a little bit more static. An example could be, your port mapping and your runtime configuration actually establishing the IP tables rules. There's more for IPAN. The bandwidth plugin actually takes bandwidth settings from your container runtime. Container D, I even attached a little code sample, which you can actually find this in the sandbox sandbox_run.go. So we're actually building up the values that will be passed in. I'm going to give a value, a little visual of that later, just so we can see what that's actually doing and how that looks. And sweet deal. So hopefully let's go ahead and truck along. This is fun. And just feel free to, throw something at me if you want me to stop or,
Yeah, Mike, I have one question here. When this port map is being used, is this used for node ports or what? Why should I use port map as a CNI plugin?
So right now, I believe when it comes to the port mapping, that actually does. I'm not actually sure if that does the node port stuff in Kubernetes. I believe that's more of if you were to use Podman or more. So that one there's a little bit of actually confusion. I took a little bit time to dive into that. So when it comes to Cryo actually implements the host port code in the container runtime. And I believe container D uses the port map plugin to do that, which this actually lays down the IP tables rules. Now, there's some confusion there because now where it comes to kube proxy and someone else may be more of an expert of that, I would be kind of curious to where that lands in, because I know there's a node port chain. So this might be a duplicated piece. So kube proxy may not kube proxy, one in the realm of Kubernetes, port map may not be used. So kube proxy may take over that role. So there's some ambiguous things who's actually doing what. So I don't think in the realm of Kubernetes this is actually used. I know if you were to go into etc cni netd directory, and depending on if you're using Podman, I think it's 87-configuration, or if you look at the default container D configuration, you'll actually see that they enable port map, which they would use via probably cryctl and more, or node, what's it called, nerdctl. So
right.
Probably not used in the realm of Kubernetes, but that would actually probably be my next one, a little presentation, dive really deep into kube proxy. But for the most part, I don't think it's used in Kubernetes, but if I'm wrong there, please let me know. I'll buy you a beer. Did I get you? Did I answer you, Amin?
Yeah, that's fine. Thanks.
Sweet. So this is what we're going to build today. We effectively are going to have two nodes. We have a control plane, and then we have a worker node, and they're joined at layer 2 just with a switch. And this effectively, let me zoom in. Sorry, guys. Forget that. You may not be able to read this. This is effectively the flannel setup using the HostGW backend. It's the most simplistic network plugin that you probably can use. It's not the most feature rich. It doesn't have network policy. So probably not the most useful. It's not feature rich like Calico, Antria, and more. So probably, move away from it. But what we're going to try to do is explain kind of the roles and responsibilities of where the CNI responsibility ends and where say the network plugin takes over. So in the case of this, if we're looking at our diagram on node 1, that we have, a network namespace, which, we can just use as a pod in this case. And then we actually have an IP address assigned to it, a default route at it, ETH0, which is a part of the P2P or VETH pair that is attached to the Linux bridge via, our VETH1. And that's effectively, the role and responsibility of the CNI. It's effectively connecting our isolation domain, a network namespace in this case, to the host and establishing connectivity there. When we start talking pod-to-pod networking, that's a Kubernetes construct. That is not a CNI construct. So, and what I mean by that is say, hey, in pod-to-pod networking, I should be able to reach this from this network namespace over here to the network namespace running on node 2. However, they're on 2 separate machines and 2 different networks. So we would actually have to do is establish routing between them. So in this case, we actually have to add a route to point to the other machine. Generally, that's not done in the CNI plugins. That's done outside of it in more of an agent or daemon set in the Kubernetes world. So you'll never really see the CNI plugin dropping routes in the root network namespace. Generally, that happens inside the network namespace itself, just because these are kind of moving targets and a little bit more dynamic. So hopefully that kind of ironed out, where these things, the roles and responsibilities lie. And obviously in Kubernetes, every pod has an IP address, and that's required for the pod-to-pod networking. It wouldn't work elsewise. The nice thing about using like the CNI is that, you don't actually need to do this setup, and you don't need to rebuild, the kubelet or, your container runtime to support. Like as an example, Calico actually doesn't use a Linux bridge. They use a VETH from the root network namespace into the network namespace itself. And you can actually kind of do whatever you want. So this may, start the unholy battle, but, with the CNI, you can actually make, very opinionated setups where, on the left side, we actually have a network namespace attached to the Linux bridge that's participating, in our pod-to-pod networking. But potentially, you have a use case where you want to schedule pods that do not participate in that. That obviously breaks a lot of things in the Kubernetes world, but you may actually have a use case, and the CNI and Kubernetes gives you that flexibility. You could replace X in this case with an SRIV device or a VLAN subinterface or more. If you require such layer 2 isolation, you could do things in a higher level, but this is just one, very opinionated way of going about your business. And for the most part, what we're going to be doing to actually complete our, our demos is that we're going to be utilizing these 2 network configurations. And I highlight the subnet because if you're going to go ahead and create your own network plugin, something you probably need to deal with is your subnetting. Because the last thing you're going to do is have IP conflicts on your network, because that may cause some grief for a lot of people. So it's just one thing that you probably want to keep in mind. The other piece that I mentioned earlier is establishing, your routes on your actual nodes to establish your pod-to-pod networking. So in Kubernetes, you probably want to make sure your subnets are not overlapping and that you have appropriate routing to get your other machines, assuming you're, layer 3 or layer 2. It depends on your network. Any questions before I hop to the workflow?
I think Jay has one about he's always get confused about what plugins are mandatory for higher level CNIs.
What was that again?
I show that in the screen. He always get confused about what plugins are mandatory for higher level CNIs.
Oh, that depends. Like when he means higher level, that depends. So as an example, Flannel itself doesn't make use of any of the community plugins that are usually in the opt CNI bin. So Bridge and Host Local, I don't believe that Flannel makes use of those. Calico definitely does not. Calico actually, I believe, unless they're dynamically calling these plugins under the covers, Calico handles everything. And you'll see in the CNI bin, you'll have 2 executables in that directory, Calico and then Calico -IPAM. So I think that's a very depends question. I think you could search around. KubeVirt, I believe, actually makes use of, I know that's not a CNI plugin, but it makes use of the bridge plugin, the community maintained one. Did that answer Jay? Hopefully. If not, Jay, woo, that looks cool. Jay, if that did not answer you, I'll buy you a beer and explain it a little bit more. Is there anything else? Any more questions?
I don't think we have any questions in the comments.
Sweet deal. So I'll see if I can get that answered. So we're going to start with a pretty in-depth workflow, and I'll zoom in. And what we're going to be talking about effectively is the CNI add, the CNI delete, and CNI check. And we're going to go from kubectl all the way down to the specific CNI plugins. In this case, we're going to be making use of our bridge and host local plugin again. And we're going to go all through the specific exported methods with the exception of a few non-exported methods. Hopefully this starts to show a pattern of how everything is laid out. And I don't have this in specific, swim lanes where I would put, the kubelet, the CRI, the specific container runtime, the CNI code, and then the specific plugins, but I'll get working on that and commit that to the CNI repo. So everybody's kind of curious of what happens, because generally when you see these workflows, you see the kubelet, the CRI method, and then you go down to the specific CNI plugins. But there's a few moving pieces between that I just wanted to capture and make people aware of. I know people have mentioned Go CNI and more, and probably OCI CNI if you're cryo people. But let's go for this. And by the way, I'm sorry, this is just Linux. I could not get the Windows side documented yet. So if you want to help me on documenting the Windows side, especially if you're a run HCS person, I'd love to talk to you. So cool. We're going to start our little journey that we're actually going to, we're a user. We're going to kube apply a specific pod, which goes obviously kube API and more, but down once it gets to, the kubelet says, hey, I noticed that I need to actually have a pod scheduled. We actually hit the sync pod, and I have the code up above in this same frame. But for here, we're actually going to say, hey, I know that I have a pod that I need to schedule. I'm going to go ahead and execute the run pod sandbox, which effectively says, hey, I need to go do something. But one piece of the puzzle that seems to be overlooked is status. The status CRI method is quite important. If you have nothing in your etc CNI netd directory or whatever directory you're using, your node will actually report not ready. So if you do kubectl get nodes, you'll be like, I'm not ready. And pods actually won't schedule to that node. So the CRI method that's implemented through our container runtimes, cryo or containerd, actually are looking for a few pieces of data. One, do you actually have files in the etc CNI netd directory? And if not, report that's not ready. And if it actually has, multiple configurations, it's going to pick the first one that's in alphabetical order. So if you have 1 - configuration versus 10, 12, and 87, 1 is going to go first here. So something to keep in mind. So we'll just assume that we have now just dropped a file in that directory. It's in the proper format. So now we're reporting to the kubelet that this node is actually ready. So we come down to run pod sandbox. And what is that actually is doing is, kind of creating the network namespace. And there's a lot of questions around the ordering of operations here, because the Docker shim had a kind of not different way, but it wasn't the most straightforward way. But in the new container runtimes, without the world of Docker shim, the container D is actually going in and creating the network namespace, and then it's actually creating our sandbox container, or what we call in the realm of Kubernetes the infrastructure container. Most people know it as the pod container, and then the rest of the containers are spun up. But before all that happens, we're actually going to call, depending on your runtime, in GoCNI, we go through setup. And setup actually goes and calls into the libcni code, which is our add network list. But if you're actually in the cryo world, you have a different method. So your setup pod with context, which nicely actually, once it hits calls our add network list, immediately after in the run pod sandbox method, they actually call get pod network status with context, which calls actually libcni's check network list and verifies, the network is actually set up the right way. And if not, it fails. Right now, GoCNI does not do that. I'm actually implementing a similar feature, but we're going to continue on. Like, what happens after add network list? The one method I said that we are going to talk about really quick is that add network list actually calls each plugin in a while loop, which then calls our add network, which is our non-exported method. And you can actually start to see that how the plugins are actually executed is with this line, which we dive in a little bit later in the next block, is that we take our plugin path, our network configuration, all of our arguments that I talked about earlier, and our runtime config, and execute the plugin. In this case, since it's add actually has a JSON result. So we're going to execute in libcni the exec plugin with result, which then calls exec plugin and executes our plugin in the flow. As a reminder, we just see the same network configuration below. There's nothing too special. So in a case of here, we're calling the bridge, which inside has an IPAM key that calls host local to assign the pod an IP address and potentially the Linux bridge. In this case, it's going to be CNI 0 and IP address. So, and we'll go through the failure condition. So if any of these pieces or anything in this flow fails, the pod setup fails. So that'll be anything non-exit 0. So if your plugin does happen to fail, please ensure that it actually does. So you actually get a nice little message that these messages are visible through kubectl, cryctl, nerdctl, and more. So it gives you a little bit of a breadcrumb to start looking at, why something failed and more. And one more piece that's really important is actually the result. And not too many people maybe some people really dive deep into this, but there's some really key pieces in here that are used. So such as the interfaces and IPs. All this is written to disk, and I have a picture here on the right that shows everything that the check command would actually use to verify that the network is still in its desired state. But the one piece I think is rather important is the IP address, because this is actually, if this IP address is for whatever reason is wrong, your pod metadata is wrong. Thus, then your endpoints are wrong. And then if you have a service and you're directing your traffic to the wrong, endpoint IP address, then you're going to have some fun, because that's simply not going to work. So that's just one of the impacts of, this being wrong in any form. But also, like, if the CNI, this JSON, it does not conform to the spec, that the pod setup will fail and this pod will never be successfully scheduled, which obviously is a big issue. So, and I mentioned earlier that a lot of these results are cached for the check. So in this case, everything is cached to var lib CNI results, the network name, which is part of the configuration list, the network configuration, the container ID, and an interface name. So up above, I given an example that we have var lib CNI container d-net the pause container ID, and then ETH0. And then more specifically, we can start to see all the values that are being passed in via the container runtime, one being the CNI args, and the other one being the capability args, which each, depending if you're using Kubernetes or more, this is passed in really regardless, have different use cases. So that covered CNI add. Do we have any questions regarding add? I think this is probably more information than most people want.
Yeah, so just to understand this part, when this output of the CNI plugin is returned, it returns to the CNI inside the runtime.
You broke up, Meme. Can you say it again?
When the CNI plugin returns, it comes back to the runtime, to the CNI implementation of the runtime. And the runtime needs to understand these fields like IPs, interfaces, and that's like abstracted by the Go CNI lib or whatever.
Yeah. So like, I think I actually have this right here. So this is in container D. So we actually capture, let's see, from setup, we have the results. So what they're actually grabbing, for the most part, from the results when it comes into container D, they really care about the IP addresses here. So that's where, that is reported back up to Kubernetes. That's where, if you did kubectl get pod and you do O-O wide, this is where that IP address is coming from. Did I get your question, or did I go way off base?
No,
so
that's
sweet
fine.
deal. Cool. So that is where generally the one piece of the information where it comes to the CNI result comes from. It literally just looks like we're just grabbing the IP address and reporting that up higher through the CRI to kubelet. And the next piece of the puzzle, obviously, is walking through delete, which is effectively the same way, just calling different methods. So, in this case, we're calling the kubectl delete and going through our kill pod, our stop pod sandbox, and continuing on. Actually, we're going to go here. However, the status command or status method actually from the CRI, if you were to say have a pod running and you actually went and replaced or deleted your contents FC CNI netd or made permissions changes to your op CNI bin, you actually could report back to the kubelet, and those pods may not actually terminate the right way, which eventually those will be rescheduled, but they'll be forever stuck in a terminating state until you resolve the issue with your node being marked not ready or whatever specific change you had made. So it's one thing to keep in mind that you can actually break your stuff, and then tear down will absolutely fail, which kind of gets a little annoying. I believe a big network plugin just kind of caused that. So from here, we're actually going from either container D or cryo or stop pod sandbox and continuing on. Obviously, for cryo, not OCI CNI, we're tearing down the pod sandbox, or we're going through remove, which effectively calls our Dell network list, Dell network, exec plugin without result. There is no JSON output when it comes to deletion. And then we actually have the exec plugin, which goes into the specifics here. When it comes to like deleting this, that the container runtime being responsible for deleting the network namespace, it actually makes life a little bit easier. However, there comes with some catches, like the host local plugin must reclaim that IP address or it'll fail. And the same with the bridge. But luckily, when you tear down the network namespace, citing back to the diagram, it tears down everything in there, obviously. So you don't need to go through serially delete ETH0, which will entail delete the VETH pipe and more. So that makes life quite easy. So if we exit code 0, everything moves forward, then that pod is actually successfully teared down. Now, obviously, the opposite, what I mentioned earlier, if you were to just go and delete your contents of etc CNI netd, you'll get an error similar to your CNI plugin not initialized. And luckily, through your kubectl, nerdctl, cryctl, or whatever CLI you're using, it should report something back to that. Sometimes it gets a little buried in the noise, but it sometimes is helpful there to at least start troubleshooting of what's going on. And one thing that I've noticed, I know is more on the Windows side, so unfortunately I can't talk too much about the Windows side, is the check command, which right now in both container runtimes, they're not particularly implemented. They're in Cryo, like I mentioned earlier, they effectively just call check immediately after add. However, there's no way to actually say, hey, I want to actually go, nerdctl containers my ID, do a check, or toggle it on some specific way, or even say, hey, if my check command fails, I want to reschedule this pod, or I want to try to reconcile the state to make it accurate. So that is some behavior that I'm trying to implement in Containerd, but it's pretty far from ready. I broke something already. The one thing is that they all go through the exact same flow. So, your method name, network list to your check network, exec plugin without result. And, that could have a result. It's not really defined there. Then obviously we call the plugin specific check command, and exit 0 and non-exit code of 0 could mean, that the state of that network namespace or the isolation domain has changed, which in tail could be, bad. I have an issue where my MAC addresses change sometimes, so that's kind of catastrophic in certain ways. So something to look forward to in the future. And I'm sorry, I skipped over questions for stop. We could do stop and check if we have any. And if not, we can just hop into some really quick manual demos. Right on. So I'm going to go hop into quick demos, actually. So let me actually scroll back to, our diagram. Is that this effectively is what we're going to do, just very manually. We're going to do one with a shell script, one just, and the shell script will just do it very statically on our control plane node. We're going to use the CNI tool not to create a pod, but a network namespace that can participate in the pod-to-pod networking. And then we're going to just drop in these 2 network configurations manually and move on. And I will be adding these routes manually. So,
yeah, just one thing. Jay has one good question.
So I wanted the whole CNI spec implemented. So right now you generally just have like add, delete, sorry about that, and not check. So I thought it would be useful for us because we do have a case that we always want to verify our network is still set up, that someone hasn't gone in with, root access and deleted, VETH. We wanted to be able to verify our TC rules as well because there was an issue that we had found. So I thought it'd be quite useful to work on the CNI check. Even there's actually a bigger one that I want to work on when the CNI 2.0 comes out, and hopefully it does land, is update, because we have business use cases to updating the network without tearing down the pod, which actually has a lot of cool, interesting problems. So that will be a fun one. And I would love to get it implemented in, Antria. Yep. That's where I started digging into the same one. So but that was on the Windows side, I believe. So the one thing that I want to do, is get with Microsoft and dive into it more, because when it comes to the Windows networking, it's a little undocumented and it doesn't actually seem to follow, the normal convention. The network setup seems to happen in the high level container runtimes, but for Windows, it looks like it's using, the run C fork, run HCS. And that's where it seems to make all those calls to the host network service, which I want to fully document. So once I get that, Jay, I'll totally help you on those things, and we'll work on the diagram and get those things implemented.
That's awesome.
Yeah, totally, because I definitely want to help you guys, or the Windows side, get a little bit more visibility on what's going on. They did just publish their latest documentation, which I can send a link. Microsoft guy, I think his name was Danny, sent it over to me. So there's some, efforts moving. I know Microsoft is making like big headway when it comes to container networking. So I think, in the future, we'll all be able to answer those questions and fix those problems with the race conditions for you guys. Cool. Hopefully I got your question answered, Jay. All righty. Let's just kick this off really quick. I might run out of time, so I might fly through these. What we're going to do is we're going to demonstrate like right now as an example. And I'll can everybody read this, or do you want me to zoom in a little bit?
The terminal is fine.
Okay, cool.
Exactly.
So right now, our nodes are marked not ready. And as I explained it earlier, Container D, and I'm using Container D, by the way, in this setup, that this is actually empty. So we need to go ahead and resolve this for both our nodes. So if I were to just go kube apply, and I can send out these files. Oh, wrong directory. Demo 1. I'm going to spin up 2 pods. We all know what's going to be happening here is that these will just continually sit here forever. So we're just going to go ahead and resolve this. We're going to actually move our network configuration that I showed you guys quite a lot, and it's just templated because I'm going to manually populate the subnet with my handy dandy script. So why don't we go ahead and do that and get things spun up. So there's no secrets here. I'm just copying this config into here. So let's go ahead and run it. All right. That should have worked. If it didn't, all right, cool. All right, so all the pods on node or control plane node will actually have this subnet, and we'll see if things start kicking off. All right, cool. And by the way, I have constraints on these pods to schedule on one node or the other. So on this case, we're now running because the pod, the node is marked ready, but node 2 is still stuck. So we're just going to go ahead and fix that really quick. Set up 2. And it should be pretty quick. Where's my get nodes? All right, come on. So that's the CNI netd directory. There's a file watch on that directory. So if you went ahead and deleted that directory, that'll cause some problems. And also why that took a little bit, there's a sync loop up in the kubelet that's also saying, I believe it's every 10 seconds or every 30 seconds. So if you miss that train, then you got to, get to wait 30 seconds. So in this case, probably all of our pods are, running. And to even show so what we had to manually do, obviously copy that, think about how we copied the network configuration to that location, but also ensure that all of our binaries are in place in Cni bin. So a lot of places, like Multis or others drop in those via the daemon set. So there's additional things you got to think of when creating your own network plugin is like dropping the files in appropriate locations, applying the right subnet so you don't have overlapping. So in this case, we have 2/24s, obviously 2 different ranges. And from node 1, I'm going to just verify my networking, but there's a problem. And I mentioned it earlier and I kind of gave it away. Whoops. Is that there's no routing established between these because we did this manually. And so most of the network plugins are actually dropping these routes in one way or another, depending on your setup. So if we want to actually establish our pod-to-pod routing, we got to actually add the routes. So we're going to go ahead and do that via 192. And I don't want to, let's see, 12 device ETH1. Sweet deal. So we just did it on one node. We obviously would need to do it, the reverse. So if I wanted to actually have our worker node, in this case, node 2, be able to ping or reach nodes on our, node 1, we have to do the same exact steps here, if I can type the right way. And these are just our egress ports. So dev ETH1. Cool. So why don't we just verify that we can actually reach? All right, cool. So real fast is that we kind of manually established, our pod-to-pod networking. We dropped in our network configuration. Our obviously our binaries are already in the right place. They came, so we made use of bridge and host local. And what I did mention earlier is that a lot of this stuff is all cached on disk, so you can actually go ahead and oops, I think I need to install JQ. Yes, sorry about that. Well, if I actually use it, so we can actually see our result, which we get it via the container runtime gets this and is not responsible for this. This is actually part of libcni. So we can actually see all the information that was passed down to libcni. And this has been cached. So now if I were to execute the check command, it's going to go and say, hey, is all of this still accurate? If not, ideally, it blows it away. So there we go. So that is the most basic setup. And this will keep working. I'm not certain how host local, the IPAM plugin handles restarts. We could find out, but not here. But that is the most simplistic way of going about, pod to pod. I mean, like establishing your own, quote unquote network plugin. I did create another one. This is like, one goes through like wildfire. And if I wanted to actually execute it, we're going to, manually go through all the steps. Like this is actually what bridge, the bridge plugin is actually doing. We're actually creating a VETH pair. We're actually moving it into the container of the pod's network namespace. We're actually going to, sudo take the role of the IPAM, assign an IP address. In this one, I just used 10.240.012/24. We're actually going to, create the bridge if it doesn't exist. In this case, it already does. We'll set the bridge to up. We'll set the VETH that's in the host network's namespace to up. We'll do the same to ETH0. And then we'll actually attach that VETH in the root network namespace to the CNI0 bridge. We'll assign an IP address, and then we'll exec and assign a default route. So if you don't assign a default route, you can only reach, IP addresses that are in that /24. So if you were to reach, 10, 20, 240.11, that will not work because you do not have route entries for that. And then obviously we have our, output. So I think that one's not the most exciting. So I think we've already hit on this one. It's pretty straightforward of what it's actually doing. The one thing I want to hit on is I want to give, utilize the CNI tool. And the CNI tool is something that the CNI maintainers, what the hell's going on here? 3. Huh. Well, that's funny. Stand by. My demo has broke. So, that's fun. Okay, so we're back in action. I don't know what happened there. So we'll go ahead and go into here. Thankfully that recovered. So the CNI tool gives you the quick ability to add, your set up your network, tear down your network, or verify your network. In this case, we're going to use the same exact network configuration that we've been using, the same /24. So we're going to execute this on node 1. And I've just made some really quick helper scripts. And you'll notice that I have like the IP netness add CNI 1234. And that's because obviously the CNI is not responsible for creating the network namespace. So if you want to do that, we actually need to do that. So part of the inputs are, CNI tool, the command, our network name. So if you want to know where that came from, network name right up here. And then our network namespace. Since we're using IP route by convention, it is in var run netness CNI 1234. And we're just going to go ahead and execute that. So right now we actually have, we have executed this as created the network namespace. It's given us all of the results that we need conforming to the CNI specification and more. We got the IP address. So if this is a case where, the container runtime, I'd pass this up higher to Kubernetes and say, hey, this is IP address, assign it to my pod metadata. And now if you have that wrapped in like a deployment and some services, the endpoints will be populated the right way. So if, like I said earlier, if that's wrong, then you're going to have some, really interesting problems. Now, if we wanted to actually execute check, since that exit code 0, that means that this network was actually stable. But if I were to go in and start hacking the network namespace, we'd have a completely different result. And the same thing for delete. So we've actually now gone through and deleted our network namespace. Is torn down everything, is reclaimed the IP address. And we can actually verify that it reclaimed the IP address because we actually don't see 10.240.05 in this directory. So that's var lib cni networks, and the network name is by convention. Sweet deal. So cool. And those are just like the very manual steps. I could have done this with any language. So nice thing about the current specification is, and 2.0 is that a CNI plugin is no more than an executable. We've proven that I can write it in Shell, I can write it in Python, I can write it in Golang, C#, whatever you want to do. It just needs to take that standard, the network configuration, be a standard in the environment variables.
So do the CNI group maintain other language plugins like
No,
for Python?
so they're all Golang right now, but you can make them in any language you want. I did just come across a project the other day. Someone had written a few plugins using Rust, which I thought was pretty cool. I don't see too many plugins that are not Golang. I think it's because all of the the tooling and the libraries behind it are quite nice and featureful. So you don't really need to jump through hoops. So if you go through Rust, someone has made a netlink package that's getting pretty big, but I'm not too certain what everybody else is doing.
That's cool.
All right. So I was going to do, instead of doing static routes, which is quite manual. So in the case if, say, node 1 were to go down in the networking world, these are static, that we'd still be pointing at, whoops, I know that is down. This IP address, we could see is down. So we can start making, our changes to our network a little bit more dynamic. And I'm just going to go ahead and delete these. What is going on? Sweet. Sorry about that. And I'll do the same over here. I just want to make sure these routes. So we're going to do this with BGP in 6 minutes. So this will be, I don't know if I'm going to get there, but we'll see. All right. Cool. Let's see if I can get this. So what I just did is I launched an FRR daemon set, which we have BGP enabled in this. So I don't want to go too deep into FRR too much, but it is a nice routing suite that has, support for OSPF, BGP, RIP, ISIS, all sorts of nice routing protocols. So quite featureful. So we're going to try to get this going really quick. So, all right. I hope this is, not going to blow up. It's probably pulling down the images. Oh, come on, internet. So while this is creating, you'll actually notice that the IP address is the node IP address because these are running in the root network namespace because we actually need to make changes to the routing table, which requires that to be in the root network namespace. My internet must be really slow today. Thank you, Snowstorm. With 5 minutes to go. Do you have any, do you have any questions while we're waiting on this to slowly pull? Sweet. All right, sweet. It just that just finished. So, all right, we're gonna configure this. There's nothing on this. Configure terminal. We're gonna use router BGP. Each BGP instance, we're gonna go with eBGP, which is exterior BGP, external BGP, and there's other iBGP, but I don't want to deal with route reflectors and more. So first things first, we need to actually establish a peering session with them. And I believe we're on this one. So this IP address is here. And this is going to get confusing really quick. We have established this session. I believe this one is advertised. We need to advertise this network. Cool. And all right, so end, show, running configuration. Cool, that's 65,000. So we're going to be pointing that over there. Okay, let's go into here really quick and completely unconfigured terminal. Router BGP 65,001. We're going to pair with our other side with our nodes, so 192.168.50.12 remote AS 65,000. We'll advertise our network, our pod network on this node. Let's see if this is actually going to show. All right. It actually looks like this BGP session has been successfully peered. And I actually, learned the route for the other network via BGP with the big B. 10.241.0 has now been added to the routing table of our master node. And we can actually go ahead and ping our pods. So we've just done pod network layer 3 using FRR. So let's just verify that I'm not a liar. Cool. We're actually pinging the other nodes. So we use BGP there. So we're actually learning routes that way. So that was it for my all my demos. I'm glad I didn't do demo 2 or we would have ran out of time. Is there any questions? That was really fast. Sorry, guys.
That's really cool to see how everything works here. And I don't see any questions in the comments. And here's one. Oh, it's not a question. Sorry about that. Do you have any question you want to ask?
No, but I think this BGP stuff is super cool, and I agree with Jay. Mike needs to come back and teach us BGP from zero next week.
Yeah, it's such a building block because if you saw that in here, let me go into one of these, show running configuration. So there's an alternative way where instead of pointing at a neighbor with an IP address, I can actually say peer with anything outside of specific interface, and that's called BGP Unnumbered, and that's for peer-to-peer connections. which is really cool. I actually really like that because I can say, hey, any neighbor that's on the other side of ETH1 automatically peer. So we can actually, in a way, simplify, our neighbor statements in certain ways. But it's also like the building block of, you had some VXLAN questions. So we can actually dig into this more where we have like data plane learning for VXLAN. And then we can actually add in BGP and even more. So we can actually have EVPN VXLAN where we're actually using BGP to exchange MAC addresses, which is super cool. This effectively VXLAN being, the virtualized layer tunnel over layer 3 is pretty cool stuff.
I mean,
So,
I am here again next week for this.
I'll try for next week. Oh boy, these are fun, but holy crap! I was like really thinking that this would go an hour and a half. I just talked really fast and skipped over a bunch of things to get in time, but I can certainly prep more content. Yeah, Jay, if you want more, I'm certainly able to do it or bring other people that are will go gaga for VXLAN. Oh, thanks, Scott. So sweet deal. Well, this was fun. Anything more, or is it time to depart? I'm still sharing my screen. Sorry, I don't know what I'm doing.
Yeah, I think it's like pretty awesome, and folks have like really fun comments there. So but like we're like run out of time, so probably we can like think more about the BGP stuff next week, maybe. And
From scratch. Oh god.
Okay. Thanks everyone for watching, and appreciate your time. See you
Definitely.
next week. Bye.
Bye.
Yeah. Peace.